Hello, this is Mrs. Scarpel, and in this video I am going to cover quadratic functions and their inverses. I'm also going to talk about what makes a function invertible. So first, let's start with a quadratic function that we are familiar with, and that is the parent function f of x equals x squared. We know that that function has a vertex at the point 0, 0, and that we can use the anchor values 1, 4, 9 to help us with graphing it. There isn't any stretch to this particular graph because it is the parent function. So from my vertex, when I go horizontally 1 unit, I will go up 1 unit, and that's the case on either side. When I move horizontally from my vertex 2 units, it's up 1, 2, 3, 4 units on either side. And when I move horizontally from my vertex 3 units, I am going to move up 9. So there's 4, 5, 6, 7, 8, 9 on either side of the vertex. And we end up with this U-shaped curve. Now, let's take what we know about finding inverses and find the inverse function for the parent function. So to begin with, I'm going to replace f of x with y. And then we know with inverses, the input and output switch places. So I'm going to switch the x and the y to have x equals y squared. And then to isolate the y, we need to take the square root of both sides. So the inverse function of y equals x squared is the square root of x equals y, or the inverse of f of x equals the square root of x. Now, I can also take these points from my graph to help me plot the points for my inverse, because again, the inverse points are reverse of my function points. So the reverse of 0, 0 is going to be 0, 0. The reverse of 1, 1 is going to be 1, 1. The reverse of 2, 4 is going to be 4, 2. The reverse of 3, 9 is going to be 9. So 5, 6, 7, 8, 9, 3. And I can do the same thing with the other side. Negative 1, 1. Negative 2, 4. And negative 3, 9. So that when I reverse them would be 1, negative 1. 4, negative 2, and 9, negative 3. And this would be the graph of the inverse. As you can see, it looks like a sideways parabola. Now, there's something we need to talk about with this particular parabola. If I draw a vertical line, let's just make an actual vertical line here, and it doesn't matter where I place the vertical line, it can go anywhere along here. I can move it anywhere along here, but what I'm going to see at every point except for the vertex, anywhere that I place this vertical line, I'm going to end up with 2 y values for 1 x value. This means that my inverse is not a function. So we would say that the function f of x equals x squared is not invertible for its domain. We have to restrict the domain on quadratic functions in order to make it invertible. So let's take a look at this next example. We have the function h of x equals 1/3 times x plus 3 squared minus 2. I know, because this is vertex form, that the vertex of my parabola is going to be at -3, -2. I also want to change this. It's a mistake here. It should say x greater than or equal to -3, and you'll see why in a minute. And we have a stretch of 1/3. So I'm going to plot my vertex, -3, -2, and I could use my anchor values of 1, 4, 9, but what I would have to do is take them times 1/3 to find out how far I need to move vertically for my points. So that's going to be 1/3, 4/3, and 3. So when I move to the right one, I'm only going to go up 1/3. When I go to the right 2, I'm going to go up 4/3, or 1 1/3. And when I go to the right 3, I'm going to go up 9. So as you can see, this parabola is going to be wider than the parent function because of the stretch of 1/3. But one thing I didn't pay attention to as I graphed this is that my domain is only for the values of x that are greater than or equal to -3. So I didn't need these points to the left of my vertex. I only need the points to the right. And my graph will look something like this. Now let's algebraically find the vertex of this function. So again, I'm going to start by writing it as y equals 1/3 times x plus 3 squared, subtract the 2. The next thing we do is we switch the x and the y, so it's going to say x equals 1/3 times y plus 3 squared minus 2, and I need to start undoing this to get the y by itself. The first thing I'm going to undo is the minus 2, and that's by adding 2. So we're going to have x plus 2 equals 1/3 of y plus 3. To undo the multiply by 1/3, I'm going to actually multiply both sides by 3. That means the x plus 2 is going to go into parentheses. I'm not actually going to distribute it. I will keep it as 3 parentheses x plus 2 equals, oh, drop the squared there, equals y plus 3 squared. Now I need to undo the squared, so we take the square root of both sides, and we now have the square root of 3 times x plus 2 equals y plus 3. And then, to get y by itself, we subtract 3 from each side. And I can't actually subtract the 3 from anything because everything else is underneath the square root. So we're going to have the square root of 3 times x plus 2 with the minus 3 outside equal to y. So our function, our inverse function, is the square root of 3 times x plus 2 minus 3, make sure that's clearly outside of the square root. So that's our inverse function. To help me graph it, I'm going to take the original function, which had its vertex at -3, -2. The next point was -2, -1 2/3. Then we were at -1, -2/3. We were at 0, 1. So I'm going to do the inverse of all of these points. That means I switched them. So we have a point at -2, -3. We have a point at -1 2/3, -2. We have a point at -2/3, -1. And we have a point at 1, 0. So our inverse is going to look like this. So if you notice, we can identify what that vertex is going to be by looking at what was in parentheses. So the opposite of negative, or the opposite of 2 is -2, and we went down 3, and the graph went this way. Went up, but didn't climb as high going up. It looks more like this one, flipped sideways and twisted. It really is a reflection across the line y equals x. Now if I draw a vertical line on this graph and I move that line, it does not matter where I move the line to. Anywhere I move that line, I'm only ever crossing the graph in one point. That means that our function h of x equals 1/3 x plus 3 squared minus 2 is invertible because our inverse is a function. If the inverse is not a function, remember we don't have an invertible function. If the inverse is a function, we do have an invertible function. And this concludes the video on inverses of quadratic functions.